Okay, now we're doing question 1 on the review for 8.6. And it says the vector v makes an angle of alpha, which equals pi over 3, with the positive x-axis, and angle beta, which equals pi over 3 with the positive y-axis, and an acute angle gamma with the positive z-axis. Find gamma. So if you look on page 645, you'll see our plan, and that is that cosine squared of alpha plus cosine squared of beta plus cosine squared of gamma must equal 1. So we've got the cosine squared of pi over 3 plus the cosine squared of pi over 3 plus the cosine squared of gamma equals 1. Well, the cosine of pi over 3 is 1/2, and if we square that, we get 1/4. We square 1/2, we get 1/4. And we still have the cosine squared of gamma, which equals 1. Well, summing a quarter and a quarter, we get a half. So 1/2 plus the cosine squared of gamma equals 1. And subtracting 1/2 from both sides, we get the cosine squared of gamma equals 1/2. So the cosine of gamma equals 1 over root 2. Now you can say, well, why isn't it plus or minus 1 over root 2? Here's why. Because for each of these angles, 0 is less than or equal to, in this case, gamma, which is less than or equal to pi. That goes for alpha also and for beta too. So, therefore, taking the inverse cosine of both sides, we get alpha, or gamma, I beg your pardon, equals pi over 4, and we're done. Now we're doing question 2 on the review for 8.6. And what we have to do is find the work done by a force of 3 newtons acting in the given direction 2I plus j plus 2k, moving an object 2 meters from 0, 0, 0, the origin, to the point 0, 2, 0. So, and this, the structure of this equation can be found on page 645, but we've already done this problem, except in just 2 space. In other words, using 2 dimensions, I and j. And that was example 7 on page 636, which is on the a similar problem on the video for 8.5. So now we're using 3 dimensions, so that's the only difference between the 2 problems, other than a little different story. So our first task is to find the, we're given that v equals 2I plus j plus 2k. Our first task is to find the magnitude of v, and so that's going to be the square root of, and each one of these coefficients squared, so 2 squared is 4, 1 squared, 1j, 1 squared is 1, and 2 squared is 4, and that equals the square root of 9, which equals 3. Now we have to find the unit vector, and the unit vector equals 2 over 3I plus 1 over 3j J, excuse me, plus 2 over 3K. Notice we have the magnitude dividing the coefficient. Okay, with that done, now the structure of our equation is going to be work equals, in fact, let me make this a very strong W. Work equals force dotted with distance, or since I've got this position vector structured in an AI plus BJ plus ZK form, I'm going to call it omega, force dotted with omega. Okay, where force equals 3, the magnitude of the force, times the unit vector, and the unit vector is 2 over 3I plus 1/3 J plus 2/3 K. And so the work, and by the way, let's define omega. Omega equals, well, since it's going over the coefficient on I is 0 and on K is 0, the only thing we have left is the coefficient on J, which is 2J. 2J, I beg your pardon, J. Okay, so then our work equals 3 times 2/3 I plus 1/3 J plus 2/3 K dotted with 2J, which equals 3 times, and so this is 0I times 2/3 I is 0. 2J times 1/3 J is 2/3 J. 2/3, I beg your pardon, we're talking about dot product. And 0 K times 2/3 K is 0. And so now the 3's divide out, and we get the work equals 2, and that's going to be 2 and Newton meters. And we're done.